high efficiency in everyday driving, instantaneous high power when accelerating. That's the kind of EV we dream of. Made possible by the balance of power, efficiency, and lasting performance. A challenge no one solved until Hyundai Motor Group did with their new motor drive system. Let's take a closer look.
Sure, sounds great.
Electric vehicles don't just move with a motor alone. The motor drive system consists of three key parts: the motor, reducer, and inverter. The motor generates torque. The reducer transfers that torque to the wheels. And the inverter, the conductor of the system, converts the battery's DC power into AC power for the motor, precisely controlling how and when that power is used.
How does it control power exactly?
The inverter consists of semiconductor-based switches. When the switches are closed, current flows. When they're open, it doesn't. Depending on the rhythm and pattern of the switches, the motor rotates and moves the vehicle forward. When AC current flows through the motor's coils, it creates a magnetic field that constantly changes as the current alternates. This shifting magnetic field pushes and pulls the magnetized rotor at the motor's center, causing it to spin.
Wow, so that's how an EV moves.
Now, let's talk about power. The power output is determined by voltage and current. To increase the drive motor's power, you can increase the battery voltage or adjust the motor's characteristics to increase current. Usually, it's the latter. But increasing current makes the motor drive system larger and heavier, and heat management becomes more difficult. Also, when designed mainly for high power output, efficiency drops significantly during everyday city driving.
So, how are these limitations solved?
That's where the inverter plays a crucial role. While it doesn't increase battery voltage itself, the way it applies and controls that voltage greatly affects the power. And we developed an innovative system that expands this usable voltage range by increasing voltage utilization. Conventional inverters use 6 switches, often employing silicon carbide semiconductors, a high-efficiency but costly material. We added 6 silicon switches, creating a total of 12 switches in our new system. As a result, the voltage that can be applied to the motor increased by about 70%.
How exactly was the voltage range expanded?
By doubling the number of inverter switches connected to a single motor, we were able to apply higher voltage levels. In regular driving, only the silicon carbide switch set is used to maintain high efficiency. In high-speed or high-output power conditions, both switch sets operate together.
Is doubling the number of switches really that significant?
It's more than just adding parts. It's a fundamental transformation of the entire control system architecture. When more switches are added, a completely new level of coordination between them becomes necessary. Like 2 riders on a tandem bicycle who must pedal in perfect sync to move forward. A conventional 6-switch inverter divides them into upper and lower sets for 3 phases, operating in 8 different combinations under strict switching rules. So, what happens when the number of switches doubles? The combinations increase 8-fold, requiring much more precise control.
To move precisely, the key must be how the flow of electricity is controlled, right?
Exactly. If you visualize the 6-switch combinations as a hexagonal voltage space vector, the maximum voltage that can be applied to the motor equals one side of that hexagon. Now imagine moving a voltage vector along that line. If it moves in steps, how would the car feel?
Like it's jerking or stuttering.
Right. That's why advanced control to smooth the voltage vectors is so important. While 6-switch control is common, Hyundai Motor Group devised a system that controls 12 switches simultaneously, expanding the usable voltage space. One module fixes 6 switches in a 6-step configuration, while the other controls the remaining 6 through 64 possible combinations. To manage these 2 voltage spaces flexibly, Hyundai Motor Group introduced a transfer switch that shifts to the optimal state depending on driving conditions.
So, the car can respond freely depending on the situation?
Precisely. The transfer switch's precise control allows smooth mode transitions, providing strong power during acceleration and high efficiency during regular and long-distance driving.
saying the whole system was rebuilt from scratch wasn't an exaggeration.
It's not just about increasing numbers, it's about orchestrating 12 switches to operate as one through an advanced control strategy.
But with all this complexity, doesn't the system get bigger or heavier?
Normally, yes, but we solved the size and weight issue with our own in-house designed power modules. The inverter's size depends on its built-in semiconductor power modules. By integrating 9 modules into 3, we created a simpler structure and improved cooling from single-sided to double-sided. Thanks to these step-by-step optimizations, we achieved a high-performance yet compact inverter design.
Wow, I didn't realize EV motor systems were this advanced.
This is only the beginning. The technology will expand to more vehicle types, and soon it will be on roads everywhere.